So there's one more type of multiplication that we need to cover, where we multiply vectors together. But before we do that, we want to talk about what's called a unit vector, because this will give us another convenient way to represent vectors. So a unit vector is, what it sounds like. It is a vector where the magnitude is a unit, i.e. that it's equal to 1. So, for example, if v is equal to 1, 0, then its magnitude is going to be 1 squared plus 0 squared, which is going to be 1. So v, we would say, is a unit vector. Now we can make a unit vector out of any vector that we want. Okay, so let's take some random vector u, and let's say it has components a and b, okay, where either a or b is not equal to 0. So in other words, we don't want them both to be 0, because if it's 0, it would just be the 0 vector, and then there's no way for us to make a unit vector out of that, right? So just to kind of look at that as an aside here, if we have some vector w which has component 0, 0, its magnitude is always going to be 0. There's no way for us to take that and multiply it by some scalar or anything like that and get a unit vector out of it, right? So this is what we would call the 0 vector. So oftentimes this will be just represented with a bold 0, or you might have 0 with an arrow over it. So going back to this, then, if either a or b is not 0, then what can we do here? Well, the magnitude of u is going to be the square root of a squared plus b squared. Okay. So if we make a new vector, say, running out of letters here, let's just call it x, I guess, equal to u divided by the magnitude of u. Now we haven't talked about division, but at this point we should know that this is really just the same thing as multiplying by 1 over this thing, right? So it's going to work the same as scalar multiplication does. So this will be equal to a over the square root of a squared plus b squared plus, or sorry, not plus, but comma, b over the square root of a squared plus b squared. Okay. So what is the magnitude of x then? So the magnitude of x is going to be this squared. So the bottom, the square root's going to go away. A squared plus b squared. Plus the second component squared. So b squared over a squared plus b squared. So we're going to add these together. We're going to get a squared plus b squared over a squared plus b squared. So this is the square root of 1, which is just 1. So we made a unit vector. Okay, so x is a unit vector. Then x is a unit vector. Okay, and you can again see right here why we need either a or b to not be 0. If they're both 0, then this denominator would be 0, right? So we would have it in indeterminate form here. But this means that we can make a unit vector by taking any vector and dividing it by its magnitude, or multiplying by the reciprocal of the magnitude if you want to be proper with the scalar multiplication. Okay, so and this vector is special in that it also will be going in the same direction as the initial vector. Okay, so when we multiply by a positive scalar, we're not changing the direction. Okay, if we multiply by a negative scalar, what it's going to do is it's going to reverse the direction. And you can see that just by drawing the vectors out. But if you multiply by a positive scalar, which this is always going to be positive because the magnitude is always going to be positive, it's going to keep going in the same direction. Okay. So sometimes we might get a problem that says something like find a unit vector in the same direction as v, which is equal to 1, 2. Okay. So then the way we would do this is we would take v and divide by the magnitude of v. Okay. And that's all you need to do. So you want to go through the calculation, of course, right? Like the magnitude of v is equal to 1 squared plus 2 squared, so square root 5. So this would be equal to 1 over root 5, comma 2 over root 5. And this would be our answer. Okay, so this is a unit vector now. You can find the magnitude if you want, and you'll see that it's 1. And it's going in the same direction as v. Okay. Now, with this in mind, what we can do now is we can use this to create another representation of vectors. Okay, so this is using what we call, sometimes they're called I hat and J hat. So again, that hat notation is more common in like engineering, maybe physics. It's not as common in statistics. But I think just when you're, in this case specifically, it's common to call these I hat and J hat. So let's take some vector v, which is equal to any a, b. Okay, so now using what we know about addition and scalar multiplication, what we can see here is that this is equal to a 0 plus 0 b, right? We can break up the two components over addition. And then we can break this up over scalar multiplication, where whatever a is, we take that out. And that's fine, because now when we multiply it back in, we'll have a and then a times 0, which is 0. And then we'll do the same thing on this one. Okay. So we can take any vector and we can write it this way. So this one right here, 1, 0, this is commonly referred to as I, or I hat. I don't really see this one with the arrow notation too much, but you could use the arrow notation here as well. And then this one right here is B, J hat. Okay, so we refer to the vectors 1, 0 as I. So again, type this would be bolded. Otherwise, you could put a hat over it, or you could put a vector over it, or whatever you want to do. Let's just pretend it's bolded. And then J is the second component one. Okay. If we bring this into 3 dimensions, I is still the one where the first component is 1. J is still the one where the second component is 1. And then we have a third one, K, which is the third component being 1. So with this in mind, we can write any vector using these unit vectors. Okay, so V equals, say, 1, 2 is equal to I plus 2J. Okay, so this is very common to write vectors this way. This is probably the most common way that you'll see in like calculus and physics and those kind of subjects. So again, we don't really do it in statistics too much because the vectors we're usually using are more specialized, right? We have like that, usually have like a matrix of data or something like that. Or we have our column vectors. So we don't really need this notation as much. We're not usually like adding things together like that. But in general, you'll see this notation very commonly. So if we have like W equals -3 5. This would be equal to negative 3i plus 5j. Okay. And again, you might see a hat here. Typed would be bolded. But I've heard most commonly, like said aloud, these referred to as I hat and J hat and K hat. But there's lots of notations you'll see, and just in general of vectors, there's kind of just a lot of notations that are just used interchangeably. So you just kind of get used to them. So I mean, just up to this point, we have the component notation, we have the unit vector notation, we have the column vector notation, the row vector notation, also with parentheses instead for the row vector notation, right? So just these things alone, I mean, that's what, 5 different notations right there. So lots of different notations that kind of just get used interchangeably here.